You are listening to the Think Brick Australia podcast. Think Brick Australia represents the clay, brick and paver manufacturers of Australia. Brick by brick, our podcast will discuss technical information and architectural case studies with special guests. I'm your host, Elizabeth McIntyre, the CEO of Think Brick Australia. I often say to people, bricks stand the test of time, and that's normally because we can see the bricks still lasting today. But on today's podcast, we're actually going to talk about testing bricks, and I'm very pleased to welcome back Keanu Andrews to talk around how bricks go through testing and why we test bricks. Welcome, Keanu.
Pleasure to be here.
So we're talking about testing bricks as they're manufactured today. Can you talk us through why we would do this?
Yeah, and it goes back to basically everything we do in modern society gets tested. So whether we're buying eggs or milk or any electronic product, there's an expectation that it meets a certain standard of quality. And from that, we have a bunch of testing regimes that all these products will go through. And the same goes for our bricks. So when you purchase bricks, there's the expectation that those bricks will be strong enough, durable enough, and actually be of the correct size to build a house in. So there's a lot of quality control assurance that comes from brickwork.
And what standards are we actually testing to, Keanu?
Yeah, so there's actually two sets of standards that we generally look at. There's the AS 4455.1 standard, which looks after clay bricks and tells you the minimum requirements a clay brick needs to meet. And there's AS 4455.2, which is the paver and flag standard, which tells you which standards clay pavers need to meet. So those are the two main standards which we look at for minimum requirements. And there's also the AS 4456 series standard set, which actually lists all those testing requirements.
Now, if you haven't got all of those numbers down, I don't want anyone to worry because they are going to be in the show notes if you're doing something else. Keanu, is it possible to test every single brick that comes out of the kiln, or how does it work?
Well, if you wanted to test every single brick that comes out of the kiln, you're going to be left with no bricks because a lot of the tests that we do are actually quite destructive.
Okay.
And those are some of my favorite tests. So in the interest of practicality, what we do is we actually only test a certain selection of bricks from each batch, and that selection becomes representative of the entire batch. So if those bricks meet the minimum requirements, then we consider the whole batch meeting the minimum requirements. And the same can be said if they don't meet those minimum requirements. We'll have to recycle those bricks and reuse them as a waste product.
And what sort of percentile are we testing to, Keanu?
So when we test our bricks, we don't use the best value because that's obviously not very fair to our consumers, but we also don't use the worst value. What we actually use is the 95th percentile. And that might sound a bit confusing for a lot of our viewers. And the best way to visualize that is imagine we had 100 people running a race. We don't use the first place time, and we don't use the last place time. What we use is we use fifth last place's time, if that makes a bit more sense.
Yeah, sure, it does for me.
And so we're not using the average or the median value. We're using a much lower value, which gives us that conservatism and confidence in our product.
Yeah, because really what you're saying is where everything above the last five is better than that.
Exactly.
Mm-hmm. Okay. So what are some of the most important tests for brick and paver products?
Well, I like to think all tests are equally important, but there are some tests that, say, an engineer would care more about than the ordinary person. So personally, I like to think some of the most important tests would be your strength test or your durability test, but a builder or a bricklayer might think the dimensional accuracy test would be the most important.
And so then how do we kind of make sure our bricks and pavers are strong enough? How do we do that?
So this test is actually really easy to visualize. Imagine you had sort of like a brick sandwich. So you had a nice piece of metal on top and a juicy brick in the middle and another piece of metal.
Okay, I just want to say to our listeners, do not bite into this.
So you have your brick sandwich, and what we do is we apply progressive loading to the metal plates. So what we're effectively doing is we're squishing that brick. If it was a softer material, what you might actually see is that brick bulging out from its sides.
Right.
And what this is called is an unconfined compressive test. And it gives us the unconfined compressive strength of that brick material.
So we're not just taking a brick and throwing it and seeing whether it splits when it lands.
No, because that wouldn't be accurate as to how a brick's actually used in a building structure. As you can imagine, when you lay it, you have the wall on top of it. So each brick has bricks on top and bricks on the bottom, and whatever loads you might have in your house. So you might have your TV, you might have your kids jumping on the wooden floorboards, transmitting that load into your brick wall. And so that brick is actually being squished from the top and bottom.
No, it makes sense now that you've explained it. How do we make sure that our bricks are the same size? We actually have done a separate podcast on the size of bricks, but how do we make sure they're all a sort of similar size when they're produced?
Yeah, and so the reason bricklayers really care about this standard here is you can imagine what it would do to your wall if you had some bricks that were larger and some bricks that were smaller, and you had a big enough variation that you started to get wonky looking walls where you didn't get straight edges, and your mortar thicknesses were varied along the length of the wall. So it's really important that we do get that dimensional accuracy. And the way we test it, and I'll be honest, it's probably really, really rudimentary. It's really simple. What we do is we line up 20 bricks in a line. So if we're measuring the length of all the bricks, so the longest side each, we'd stack them, or we'd lay them side by side, 20 units. And what we'd do is we would measure that length overall, and then we would compare that overall length to what the length should be.
Yep.
So let's do some quick maths here.
Okay.
Just a quick test for Elizabeth. If we have 20 bricks and each brick should have a 230 millimeter length, then how many millimeters should we have for the 20 bricks?
So I'm doing 230 times 20, which is 4,600.
Perfect.
Okay.
So you have 4,600 mils. So we do the test and we'd actually measure that length. And the difference between the actual length and the assumed length, which is the 4,600 millimeters, would allow us to classify that brick into a certain dimensional deviation category.
Right.
And that dimensional deviation category is specified on the manufacturer's specification. So builders, homeowners, engineers know what they're buying into.
And they know that it's been tested.
Exactly.
Now, Keanu, in Australia, we're an island, and obviously surrounding us is a lot of salt and things like that. What sort of other tests are bricks subject to?
Probably the most important tests for an Australian would be the salt resistance test. There are some other durability tests that are available. One might be the freeze and thaw test. But as you can imagine, we don't get much snow in Australia. And with that, we don't get much ice. And we definitely don't get that melting and freezing cycle. So probably the most important would be that salt resistance test. And all bricks are classified as either an exposure grade brick, a general purpose grade brick, or a protected brick.
And so, again, we've got a podcast on that as well.
Exactly.
Yeah.
So I won't go into the details of that. And if you do, I'd highly suggest that you go check out that previous podcast. But the way we test it, and again, it's quite simple, and it might seem like the material scientists and the laboratory technicians are a bit lazy. But what we do is we take a small cutting of that brick, and we'll weigh that when it's dry.
Okay.
And so that gives us our control. So we know if the brick is 50 grams, we know before testing it was 50 grams. What we'll do now, if we wanted to test an exposure grade brick, we'd soak that sample in a sodium chloride, so salt water solution, or sodium sulfate. There's no layman's terms for sodium sulfate, but that's what we would use. And so we'd soak that until it was fully wetted, and then we'd remove that and dry it. And what we'd do is then wet it again.
Okay.
And then dry it. And what we do, we do that for about 40 cycles.
40 times.
40 times.
Wow.
And that's the expectation that's listed in the standard.
Yep.
After the 40th cycle, we'll finally dry that material. And so what's happening as we're wetting and drying it is we're getting salt particles inside that brick. And when we're wetting it, we're getting salt water into the brick. And when we're drying it, that salt water, or the water in the salt water, evaporates. And what we're left with is those nice salt crystals which expand during the drying. So each time it's displacing more and more clay material
Yep.
and resulting in some mass loss.
Okay.
Okay. Obviously, the test is a lot more significant than you could really expect in a home building application.
Yep.
You're not going to be soaking your bricks in salt water
No. 40 times.
40 times over a period of, say,
Unless you live in a lighthouse, but yeah.
So what we do is we compare the original mass to the final mass of the material.
And what are we looking for there?
We're looking for something below 0.4 grams.
Okay. Of a difference.
Of a difference. The difference we're looking for is quite minimal, but it gives us reasonable confidence that this brick will perform in high salt or high acidic environments, which is really important, particularly around the Australian coast. You wouldn't want to build your home in something that isn't resistant to salt attack if you're building on the beach at Bondi.
No, I think we've had a great summary, and I guess the key points that I'd take out of this for those of our listeners that are wondering how bricks are tested and how they maintain their consistency. Firstly, is that as an industry, all of our manufacturers test their bricks regularly as to their strength and compression, as to the size. And for those bricks that are going to be classed as exposure grade bricks, they've just been tested almost 40 times before they are allowed to go to site and be built with. Would you say that's the key summary?
I would say that's a perfect summary of what we've spoken to today.
And look, Keanu, as you know, I always like to do something else while I'm listening to podcasts. And I did mention earlier that we would put a lot of these figures in the show notes. But where else can people go to find more information about brick testing?
The best place to start is always the technical section of our website. We have manuals that go over the specification of clay bricks, and there's a lot of information about how or where you can find testing requirements. The other place that you could always come to is just calling us directly. We have a technical team dedicated to answering your inquiries, and each inquiry is treated with the utmost respect and is extremely important to us. So it doesn't matter if you're a homeowner, builder, or engineer. We want to see your project flourish. So give us a call and we'd take you from A to B. Absolutely.
Thanks, Keanu, and thanks for joining us today to talk about how bricks are tested before they make it to site.
Thanks, Elizabeth.
If you have enjoyed this podcast, please follow, rate, and review our podcast. We are always looking for new ways to think brick. If you have an idea of what you'd like to hear about, there's a link in our show notes to let us know.